To define a single-phase overhead wire, click on the wire symbol. Toggle off all but one of the phases when selecting the from and to connections. A single-phase overhead wire is visualized by a single solid line as shown here. The wire editor is organized as 3 panels, each exposing a higher level of data complexity. Let's take a closer look at the various input requirements for properly modeling a single-phase overhead wire. Raw conductor data and geometry are used to compute impedance via OpenDSS. The first step is to provide conductor data for both the phase and neutral wires. Additionally, we will need to indicate the position of the conductors. Consider the following configuration for a 2-conductor single-phase overhead wire installed on a 30-foot utility pole. The B phase wire is at x-coordinate 4 and at a height of 25 feet from the ground, while the neutral wire is at x-coordinate 0 but at a height of 20 feet from the ground. If you have a specific earth resistivity value, you can also enter it for earth correction factor computation. This conductor position information is required and must be entered in the geometry data panel as phase and neutral wire x and y coordinate values. Let's return to the editor and look at some of the other features available. In order to simplify the design workflow and minimize the need for nameplate data, a library of wires is included that provides typical input data for a desired wire type. You can manually sort through the catalog or filter the list by simply typing what you're looking for. As mentioned, the conductor positions must be defined for each wire as x and y coordinates. Wires can also have protective devices assigned on their from and to sides as shown here. This concludes our short tutorial on single-phase overhead wires.